Okay, so today we're going to look at number 29. So let's see what we got. Let f be the continuous function on negative 4 to 3, whose graph consists of this stuff on the right and is centered at the origin. Let's see. And it's also given that g of x equals the integral from the integral that's given. Yeah, I'm being kind of lazy in my reading. So, in other words, just to be clear, this is f, which happens to be related to g of x. So, let's start with letter A. Find g of 2 and g of negative 2. So, g of 2 is going to be the definite integral from 1 to 2 of f of t dt. So what are we going to do? We are going to find the area underneath the curve from 1 to 2. So in other words, I want to find the area of that little triangle. And I just have to, as I'm going to go and do this, I do need to make note that it's below the x-axis, so it's going to be negative. And there's a couple ways I can approach that. One is I could just plug in my numbers. So since it's the area of a triangle, it's going to be 1/2 the base, which is the distance from here to here, which is 1, times the height, which is down, which is negative 1/2. Okay, so we end up getting this to be negative 1/4. Okay. By the way, if you're like, well, how did you know that it was negative 1/2 for the distance from here to here? What I ended up doing is I looked at the slope of the line from here to here, and I saw that it was the slope of the line is negative 1/2. And so since I went over 1, I had to go down 1/2. Okay, let's continue. Let's go find g of negative 2. So g of negative 2, very similar, is going to be equal to the definite integral from 1 to negative 2 of f of t dt, which I'm going to use our properties to flip those limits of integration. So we go from least to greatest. And in order to do that right, I have to make it negative. So now let's kind of look at what we are examining here. So now what we are looking at is we're looking at the area underneath the curve that starts at negative 2. So from here, and is all this stuff, right? So it starts from negative 2, goes all the way to 1. So let's go and do that. So that's going to equal, first off, it's negative whatever that area right is because of this negative sign here. So what do we get? We get the area of that triangle, and that area of that first triangle, it's 1/2, the base, which is 1, and the height, which is 3. Okay? Then, right, I'm going to kind of talk about this in two different ways. I'm going to deal with this area right here. Now, because it's below the x-axis, I want to make sure that that whole thing's negative. Whether I just kind of recognize it as negative and deal with it as a negative, or if I make one of the dimensions negative, that's up to you. So what I'm going to say is I'm going to say minus, I'll just do this in a different color for no particular reason, the area of that semicircle, right? Because again, the semicircle is below the x-axis. So that is going to be, area of semicircle is 1/2 pi r squared, where r is 1, so 1 squared. Okay, and that's all we need to know. So from here, simplifying this, we get negative 3/2 minus, looks like pi over 2. Right? I didn't mean to pull that negative in yet. So this gives us negative 3/2 plus pi over 2. Okay? So that is letter A. Let's go find letter B. So let's see if I can grab it. Nope. I'm going to erase. I'm going to erase. Goodbye. And hello, letter B. What do we got? For each of g prime equals -3 and g double prime equals -3, find the value or state if it does not exist. Okay, let's start with the first one. They said g prime. So I'm going to start with g prime of x. And I think you'd agree g prime of x. So actually, let's backtrack one step. Probably don't need to, but let's start with, I'm just going to say for completeness sake, I'm going to say g of x equals this, right? That was just given. And then, I think you'd agree, I'm going to take g prime of x. So g prime of x equals the derivative of the right-hand side, which second fundamental theorem says is f of x. So then, I want to go find g prime of -3. So g prime of -3 equals f of -3. And if I go to my graph, let's clean this up a little bit. F of -3, where is -3? 1, 2, 3. So it is this thing right here. And I think you would agree. And again, we could go and figure it out to be sure, but it's I know, right, that it is a height of 2. Again, we could go and figure it out. You could go and write the equation on line or something like that. Go find the slope, however you want to do it. But again, it is -2. So f of -3 equals +2. I don't know. If I said -2, I didn't mean -2. It's +2. Okay, so it's this height right here. However you find that height, whether you eyeballed it or whether you figured it out, calculated it out. Okay. I would be sure if you do eyeball it, just kind of double check it to make sure. I mean, you might be right, but it could be off. And like I said, you could always write the equation of this line, then evaluate it at -3 if you wanted to double check or something like that. Anyway, I know I'm getting caught up on that one. I just want to emphasize the fact that eyeballing it is not the greatest way of doing things. We should be certain, and I am certain because I did double check it earlier when I was doing this problem. Let's continue because I'm rambling now. Let's go to g double prime because they're asking for g double prime of -3. So first off, since I already know that g prime of x equals f of x, right? I've already stated that here. Then I can go g double prime of x equals f prime of x, right? And so now what do I want to do? I want to evaluate g double prime at -3, which equals f prime of -3. So now what I'm really trying to do is I'm trying to find the slope of the tangent line, right? I'm trying to find the slope of this tangent line because that's tangent to the point that's given. And so now I have to look, so I'm going to go and find that slope. So let's go and find that slope. So it's y2 minus y1, so 3 minus 1 divided x2 minus x1, so minus a minus or plus that, so plus 4. So this is 2 over 2 or 1. Okay? That's all there is to be. Let's move on to letter C. Okay, what do we got? Find the x-coordinate at each point at which the graph has a horizontal tangent line. So question 1, we're going to find the x-coordinate for which has each G has a horizontal tangent line. Then part 2, for each of these points determine whether it has a relative minimum, relative maximum, or neither. Okay, so there's really 2 questions here. Question 1 is about finding the x values where they're horizontal tangents. The second question is all about minimums and maximums. Okay? And then, of course, they do ask us to justify our answer. So let's see what we can do. So the first thing I'm going to do is I think you'd agree, in order to find minimums and maximums for this thing, I'm going to say, let's say G has horizontal tangents when g prime of x, which I think, again, we've already did this earlier, that equals f of x, right, equals 0. So we've already established that g prime of x equaled f of x, but now I'm saying when f of x equals 0, right? But I am pointing. I can't just say f of x. I really want to point. Here's g. Here's what I'm looking at. Okay, So I think you'd agree there are two places where there has to be horizontal tangent lines, because there's two places where f of x equals 0. So those two places, the places are, let's see. How about, let's say, I want to just sound smarter. So I'm going to say, which occur at x equals -1 and x equals 1. Okay, orange highlighted part taken care of. I've said there are some horizontal tangents here. Here they are. Okay, the second part. Now they want to know, are they relative minimums, maximums, or neither? So let's, again, this is just for talking purposes. Let's go and plug those numbers in. So we have -1 and 1 to our sign chart, right? So this is G prime. Again, AP is not going to look at this. So to the left of -1, I think you'd agree the graph lies above the x-axis. So in other words, it's positive. To the right of -1, it lies below the x-axis. So it is negative. So we have a maximum at -1. Now, let's look at 1. So again, to the left of 1, we already know it's negative. To the right of 1, I think you'd agree, it stays negative, right? It's still below negative. So in other words, we have a stall, neither a minimum nor a maximum at 1. Okay, so at -1, there's a maximum. At +1, there's neither a minimum nor a maximum. And so let's go and justify that. Let's go and put that together. So I'm going to say, and I'm going to type it out because I'm a faster typer than I am writing it down. So I'm going to say at x equals -1, G has a relative maximum. Yep, because G prime, which equals F, changes from positive to negative at that point. Okay, that takes care of x equals -1. Then I'm going to say at x equals 1, there is neither a minimum or maximum, because G prime, which equals F, does not change sign at that point. Okay? That is letter C. I think that's all they're asking. Let's just double check. Yep, we justified it. We found them. Yep, that's all it's asking. Okay, letter D. From -4 to 3, find all the x values for which the graph has an inflection point and then justify. Okay, so basically this whole graph goes from -4 to 3, so we just want to find all inflection points for G. So in other words, right, I'm trying to determine where F, right, changes from increasing to decreasing or decreasing to increasing. So I think you'd agree the graph of F is increasing here, but now it's decreasing. So we have an inflection point here at x equals -2. Then we're decreasing, and now increasing. So at x equals 0, there's an inflection point. And then finally, we are increasing, decreasing. So we have an inflection point at x equals 1. So there are 3 inflection points. So we've discovered them, or we found them. Now we just need to put it all together. So we're going to put it all together. So what I'm going to say here, I'm going to say, and actually I think I'm just going to type this again. So letter D. So there are 3 inflection points at 3 inflection points. They are Okay, that's probably not the best way of saying it. X equals, let me just double check, -2, 0, and 1. Okay, X equals -2, X equals 0, X equals 1. How do we know? There are 3 inflection points at X equals 0. They are inflection points, or I'm trying to make it myself sound a little bit smarter than what I'm going to write here. We know they are inflection points, because at those points, so G double prime of X, right, which equals F prime of X, right? So now I'm talking about F prime of X. What is F prime of X doing? F prime of X, so if this is the graph of F prime of X, our slope is positive to the left and then it's negative. So it's changing sign because I'm talking about F prime. So we know they are inflection points because at those points, F prime of X, I can't write, changes sign. Okay? Now, I could say if I want to, that's fine. That works because I'm talking about F prime and I'm saying it changes sign. What I could have also said, and it would have been fine, I could have said, we know there are inflection points because at those points, God, that's pretty poorly phrased, isn't it? No, I guess it's fine. I don't know how I'd say it better. But okay, sorry, I got distracted. So what I could have said instead is I could have said, we know that there, so kind of think of this as like option 2, right? I could have said, we know they are inflection points because G prime of X, which equals F of X, F of X, changes from either increasing to decreasing or decreasing to increasing at those points, at those X values. Okay, so here's the difference, just in case you're wondering what the difference is. In the first one, right? So I'm gonna highlight one in pink. So in this one right here, and then I'll highlight the other one in orange. Okay, in the pink one, I say, look, I'm going to look at G double prime of X, which equals F prime of X. So because I'm talking about F prime of X, what is F prime of X doing? Oh, F prime of X is changing from positive to negative because the slopes of the tangent line to the graph of F are at first positive, then they're negative, or they're then negative, then they're positive. So the signs of their slopes are changing. In the second one, the difference is I'm saying, hey, I'm looking at G prime of X, which equals F of X, and I'm trying to determine, is G prime increasing or decreasing, right? I'm taking the derivative of G prime, which is the second derivative. So just be clear, either one is fine, but if I'm going to remember, if I'm talking about increasing or decreasing, those are derivative words. So if I'm talking about G prime increasing, right, I'm saying I'm taking the derivative of G prime, which is the second derivative. Okay, so that increasing, decreasing represents a rate of change. It represents me taking a derivative. Anyway, that is problem number 29. I hope you enjoyed it, and I will talk to you next time on, I think, problem number 30.